Alright, as you can see in the very bottom, I have the balance equation, since we're going to be using that throughout the video. And for starters, we're going to start off with 175 grams of Fe2O3, and we're going to times that by 1 mole of Fe2O3 all over 159.7 grams of Fe2O3, which is going to be the actual mass of all that combined. And then I'm going to have to times that by 1 mole of iron, since you're trying to figure out how much iron is produced for this equation. And you're going to do 1 mole of Fe2O3, since we're trying to cross out both of these, which is also going to go into effect for grams of Fe2O3 and grams of Fe2O3 for this also. And then for the final part of it, we're going to be doing the 55.85 of iron, since that is the mass of iron on the periodic table. And then we're going to be doing 1 mole of iron, so that it crosses out here, 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 and the last part. Since we have that done, then you only have to multiply the 175 times the 55.85 and then divide all that by 159.7 grams, which is going to give you a final product of 61.2 grams of Fe, which is iron. And now that we have the first part of the problem done, we have to move on to the second. For the next part of the equation, you're going to start off with the 37.5 grams of aluminum, since that is going to be the second part that is going to give you iron. And since we have that part, we're going to times it by 1 mole of aluminum, since it only has 1, and it's going to be the weight of 26.98. Alright, so we're going to start off the second part of the problem, which is going to be the 37.5 grams of aluminum, which is going to be times by 1 mole of aluminum. So we're trying to change it over to mole, which then going to be over the mass of aluminum, which is going to be 26.98 grams. And then we're going to times that all by the 1 mole of iron, since it's only going to have 1. And it's going to be all that over 1 mole of Alright, so now that we have the first part done, we're going to move on to the second, which is going to be the 37.5 grams of aluminum. Going to be times by 1 mole of aluminum over the atomic mass of aluminum, which is 26.98 grams. And it's going to be times by 1 mole of Fe, since we're still trying to figure out how much iron is produced and what is a limiting reagent. And then we're going to be putting 1 mole of aluminum under, since we're trying to cross these out and only get the mole of Fe. And then we're going to times that by 55.85 Fe grams all over 1 mole of Fe, since we also want to cancel out the moles and just leave it with grams of iron. And since we're doing that, cross out, got all that. And then we're going to times the 37.5 times the 55.85 grams, all divided by 26.98 grams, which which is going to leave us with a 77.63 grams of iron, or Fe, which, since we had originally 61.2 from our earlier equation, it's actually going to be the limiting reagent for this problem is going to be aluminum.